So our next result is about the union of piecewise smooth curve. Okay, so geometrically, if sorry, so this is a piecewise smooth path in the space. It is a smooth. It is three piece of. It is the union of three piece smooth curve. Uh, Altogether, this is a piecewise smooth path in the space. But we can also have the another piecewise smooth path. This is the union. They join together here in this point, in this red points. So intuitively, the union of two piecewise smooth paths should be also a piecewise smooth path, right? But we need to prove this analytically. So this will be very important in our future discussion. So we state this result as a proposition. Let C1, C2 be piecewise smooth path having a common endpoint. Each curve, each path has two endpoints. Okay, but if these two paths have no common endpoint, you cannot join them together. Two curves, one is here, the other is here. You cannot consider their union. It is not a path in our sense. Okay, so we require these two paths to have a common endpoint. This is the condition that we can join these two paths together. Okay, then the conclusion is that the union is also a piecewise smooth path. Okay, so let's prove this result. We might take the parametrization of this path. Okay, Ci has parametrization gamma I. Gamma I is a map, a continuous map from AI BI, because for I equal for gamma 1 and gamma 2, the domain of definition might be different. So we have to denote the domain of definition of this gamma I to be AIBI, not the same AB. Okay. So they have a common endpoint, means that we might assume gamma 1B equal gamma 2A. Gamma 1BI, gamma 1B1. Gamma 1B1 is the endpoint of C1. And we assume that they are because they have a common endpoint. So this the ending point of gamma of C1 would be the starting point of C2. So analytically, this means that gamma 1B1 is equal to gamma 2A2. Okay. Then we define a map. We need to we want to prove that C1 union with C2 is a piecewise parametric piecewise math, a piecewise smooth path. Okay, so so we need to construct a piecewise smooth parametric path whose image is C1 union with C2. So we need to define the gamma. So This is C1. This is C2. So we need to combine the gamma 1 and the gamma 2 to construct a new path. How to do this? So we define this gamma as follows. Gamma B1 plus B2 minus A2. Let gamma T to be gamma 2 T plus A2 minus B1. As you can check, this gamma is also a parametrization of C2. So if I denote this interval by I, then gamma I is emerge is also C2. So this gamma, the new parametric patch constructed using gamma 2, our gamma is also a piecewise smooth parametric patch whose image is C2. Now we use this gamma. In other words, this gamma is simply the parametrization of gamma 2. We switch the variable from t to t plus a2 minus b1. This will make it convenient to join the two paths, gamma 1 and gamma 2. Okay, so using gamma 1 and this gamma, we defined the union eta to be gamma 1 joining with gamma 2. What this means? This is a parametric path defined over A1, B1 plus B2 minus A2 to Rn. Defined in this way. Eta t is gamma 1 t if t in the interval A1, B1, and equal gamma t if t in the interval B1, the second half of this interval. That is, eta t move along the curve. When t equal to A1, it is here at the starting point of gamma 1. Then in the time interval, we consider t as time. In the time t, when the time t belonging to the A1, B1, it traveled along C1 and end at the end point of C1. So this completed the travel during the time A1, B1. Then after the time t equal to B1, it traveled along the curve C2 in the pattern of gamma. That is here. Then from this up, it traveled in this manner. So its trajectory is precisely the union of C1 and C2. And since gamma 1 and gamma 2 are piecewise smooth, so you can check that gamma is piecewise smooth. Therefore, our eta defined in this manner is also piecewise smooth. Okay. So so this is a very intuitive property. Now we can give further examples. Suppose G and H is continuous function defined on AB, and they are continuous and having bounded derivative in AB. Okay, two real-valued functions G and H, they are differentiable in the open interval and with bounded derivatives. Okay, so if G is less than H in the open interval, then we have a so-called simple domain. When we study Fubini theorem, discussing the transformation of multiple integral into iterated integral, we introduce the concept of a simple domain. Simple domain is omega for x, y, x in a, b, y belongs to G, the open interval gx, hx. Okay, since gx is always less than hx, we can define this omega. So in the picture, so this is A, this is B, so this is our gx, y equal to gx, and this is y equal to hx. So this simple domain omega is the domain bounded by these two curves and the vertical boundary. So this is our omega. Then the boundary is piecewise smooth. The boundary of this simple domain is piecewise smooth path. Why this is piecewise smooth? So let's have a look on this. The boundary of omega has 4 pieces. So this is the first pieces, this is the second, this is the third, this is the fourth pieces. So the vertical part, that is 2 and 4, are segment, straight segment, smooth. Okay, and the lower boundary, that is the curve 1, is also smooth because it is the graph of a differentiable function. Therefore, it is a smooth piece, smooth curve. And the number 3 is also smooth. For example, C1, that is the number 1 curve, is the image of this gamma 1, AB to R2, gamma 1 T is T, GT. Since G is smooth, so gamma 1 is a smooth smooth parametric curve. So C1 is a smooth path. Okay. Similarly, C3 is also smooth, and it is easy to check that 2 and 4 are also smooth. So in conclusion, the boundary of this omega is the union of C1, C2, C3, and C4. Now using our previous proposition, that is the union of 2 piecewise smooth pieces. If they have common endpoint, then the union is also a piecewise smooth piece. So using this proposition, of course, this proposition involving only 2 piecewise smooth pairs. Okay, so we can use that proposition several times. We will conclude that this is piecewise smooth because this is C1 and C2 are smooth. Therefore, C1 union with C2 are piecewise smooth. Piecewise smooth, the union of C3 then is also piecewise smooth. But so this is the union of the first 3 part is piecewise smooth. Then union with the last part, which is a smooth path, so resulting piecewise smooth path. So this is a very useful example of piecewise smooth path. That is, it is a boundary of the simple domain, 2-dimensional simple domain. Okay.